All right, 1.2, we are exploring the validity of conjectures. So remember in 1.1 we talked about, is this conjecture reasonable? Okay. Another way of putting that is this conjecture or this idea or your conclusion that you're drawing here, is it valid? Or is it true for most cases, at least most cases, okay? If you are a grade 10 student here at RCS, are you here at RCS during most weekdays? Yes, during the most weekdays you're here at RCS if you are a grade 10 student here at RCS. That's a valid conjecture. Why? Because when you look at the calendar, most weekdays of the year, including all the holidays in summer, most of those days, over half, you're here at some point during the day. So that's a valid conjecture. If you're a grade 10 student at RCS, are you in Cancun most days? No, you're not in Cancun most days. Some of you maybe go there during the school year and miss a lot of school. But no, you're not there most days. So that's not a valid conjecture. No, oh, grade 10 students, where are they right now? No, they're not in Mr. Maxwell's class. They're in Cancun. Oh, okay. That's a pretty cool school. Yeah. Any votes that we should maybe have class in Cancun instead of having them here during the winter at least? Yes? Okay. We have some votes. I will propose that to admin, and we'll see where it goes with that, okay? So flights might be a little pricey, but, you know, hey, we can do it. We can live on the beach, sleep in a palm tree or something, on a hammock, get up and do math. Okay, but I digress. All right, let's take a look at these pictures on page 16 in your textbook. Okay, are you guys ready? You with me? Look at this one. Make a conjecture about the diagonal AB and diagonal BC. Now, you're just looking at this and you're making some conjecture about this. How does it look? What does it appear like to you? And how can we check it? So don't do any measuring right now. Don't do any measuring. Just look at that. How does AB, that diagonal, and BC, that other diagonal, how do those compare, do you think? What does it look like? Okay, it looks like they might form a 90-degree angle. Okay, okay, okay. That's a good idea. What else?
They might be the same length.
Okay, they might be the same length. Does one look bigger than the other?
Yeah.
The way this is drawn, it looks like AB is bigger than BC, but they look pretty close. So they could be 90 degrees. They could be the same length. Okay, all right. Now, is there a way we can test either of those conjectures? Okay, a ruler, we can measure the length of them, okay? How many of you have a ruler with you? Okay, grab your ruler if you have it with you. Remember, you should be bringing some instruments to class. Pencil, eraser, calculator. You can bring a ruler, have that in your binder. A protractor if you have one. You know, the half circle with the angles on it. Those things are pretty, a calculator I think I mentioned. Okay, so measure these lengths and someone tell me if AB is longer than BC. What are we finding? All right, so you get a ruler out. That's one way you can check these conjectures, right? This is 2.7 centimeters, and this one is 2.7 centimeters. They are the same length, even though they don't look the same length. Now, a quick calculation on the angle there. It does not appear that the angle is 90 degrees at all. If you get a protractor out and you measure that, this one is about 105 degrees. So this is not a 90-degree angle. But again, how can you check? Well, we have instruments, right? You have calculators, you have rulers, you have protractors. You can check the validity of this conjecture, okay? Now, let's move on to the next one. What do these inner circles, the inside circles, okay, check these out. Okay, all right. They look different in size, don't they? Compared to what they're around. Look at this circle, looks really small. This one appears to be pretty large, but if you get your ruler out and you measure them, they actually measure to be the exact same width of about, what, 0.6 centimeters? They're exactly the same size, okay? So this looks bigger, and this looks smaller, right? But they're the same size, and we can check that with the ruler. Okay, What about these two? This is pretty cool. Okay, so this right here, there's obviously some kind of bulge happening, right? In the paper, it's like there's some kind of like marble or a rock that's like sticking through the paper, and that paper looks like it's protruding in the middle, and those lines appear to be what? They look like they're kind of like bowing out, don't they? Okay. Now, if you have a ruler, this is easy. If you don't have a ruler, what you can do is take your textbook and you can tilt it on the side like this, and with one eye, look at the lines, and what you'll find is if you view it from more the top, those lines look like they are curving out, but when you actually tilt that sideways, those lines are exactly straight. So again, with a ruler, I don't know if I can do it on here. Okay, with a ruler, no, I'm gonna try this. Oh, what happened here? Okay, my computer's glitching here, but okay, check this out. This is a straight line. That is just weird. Check that out. Can you check that out? Let's see. Isn't that messed up? That line is straight line. That's crazy. Now the straight line does not look straight, but check it out. See? That's a straight line. Okay, that's messing with my view of reality right now. Okay, and what about sideways? Are the sideways lines straight too?
Yeah.
If you do the same thing with your eye, look at that, the sideways lines. So just how the black and white things are arranged, it fools your eyes into thinking that it's some kind of like zoom perspective, like it's a perspective drawing. That's what it looks like. Okay, finally the last one here, this one, make a conjecture about the number of triangles that you see. How many triangles do you see here?
2. 0.
Oh.
Infinite, 2, 0?
It's imaginary.
8?
No, yeah.
8?
13.
It's 13? Okay, I like this one. Okay, what is a triangle?
A three-sided shape.
A three-sided shape. Okay. Now this shape also, the sides are straight. Okay. The sides are connected, so it has 3 points of connection as well. So it's a closed figure. Now, it appears that there's a triangle here. Is that a triangle?
Yeah.
No.
No, why not? What's wrong?
Because it's not connected.
Because it's open, it's not closed. Okay, there appears to be a triangle right here too. What about this one? That one looks closed, doesn't it? Yeah, but there's no lines connecting them, right? So it kind of like, yeah, it looks like, hey, that's a triangle. And doesn't it look like there's a triangle here too? But again, it's not a closed figure. These ones look like they could be triangles, but it's not a closed figure. So what would you say? How many triangles exist here?
0.
Or is it a trick question?
0. Isn't that funny? Isn't that funny how your mind can be tricked? So this is a really good example, guys. This is a really good example of you have to test things, okay? Test things out. If there's some kind of standard that you can measure things by, a ruler, protractor, a clear definition, the definition of a triangle, a calculator, okay? That's how you can test the validity of conjectures. Okay, now, I am not going to go through all of this with you. There's three questions, okay, that I want you to do 1 to 3 for number 1.2. So what I want you to do is I want you to make a conjecture before you do any measuring or anything like that. Boys, can you quit bothering each other? Before you do any measuring or any standardized checking the validity here, I want you to make a guess as to what you think is going to be the same or different about these tables. So what conjecture can you make about the dimensions of the two tabletops? So the length, width, even the height if you want. Okay? How can you determine if your conjecture is valid? That's number 1. Number 2, examine the pattern below. Now this is very similar to the one we did earlier, okay, about the 17 times 11 and 53 times 11 and so on. Here's another pattern for you to look at, and I want you to test to see if this pattern continues, the pattern that you notice, describe the pattern, and then test others to see if the pattern continues, or where it doesn't continue, or what kind of criteria needs to be met. Okay, so examine the number pattern, make a conjecture. What steps can you take to determine if the conjecture is valid, and go ahead and do that. Okay, and number 3 I don't have up on the screen here, but number 3 talks about 2 septagons or heptagons, 7-sided figures. Okay, so that's just a brief introduction to 1.2, exploring the validity of conjectures. Right now we are not talking about mathematical proofs yet. We're just talking about find a whole bunch of examples to see if this conjecture is valid, or if there's some examples that don't fit. Okay? 1.2. There you go. There's your little mini lesson for 1.2. 1 to 3 is your assignment. See you later. Any parting words? Any parting words for those watching the video?
Happy birthday, Ethan.
Happy birthday.
Oh, happy birthday, Ethan. Wake up, Ethan. It's your birthday.